NASA's New Horizons spacecraft, one of the most ambitious deep space missions ever undertaken, achieved a historic milestone when it conducted the first and only flyby of the Pluto system, culminating in its closest approach to that distant and mysterious world in July 2015. This moment was not only a technological triumph, but also a profound scientific breakthrough, revealing Pluto in unprecedented detail and transforming humanity's understanding of what was once considered a cold, featureless ball at the edge of our solar system. Instead, Pluto was revealed as a dynamic world with nitrogen glaciers, hazy atmospheric layers, and a complex geological history. But the New Horizons mission did not end with Pluto. After completing this groundbreaking encounter, the spacecraft continued its long journey deeper into the Kuiper Belt, sailing onward through the frigid outskirts of the solar system. This onward trek led to its successful flyby on January 1, 2019 of Arrokoth, a small Kuiper Belt object, or KBO, notable for its unusual snowman shape, composed of two lobes that appear to have gently merged billions of years ago. Arrokoth resides in a region of space beyond Neptune known as the Kuiper Belt, a vast zone filled with countless icy worlds that are remnants of the early solar system. These objects are essentially pristine samples of the primordial material from which planets and moons formed, making them scientifically invaluable. The Kuiper Belt itself is populated by a diverse assortment of frozen bodies, sometimes referred to as celestial leftovers, because they represent building blocks that were never incorporated into larger planets. For the New Horizons spacecraft, the journey has always been about more than reaching specific targets. It is about pushing the limits of human exploration and continuously gathering data about the most remote regions of the solar system. More exploration science, in many ways, is always on the horizon, both literally and figuratively. Late last year, a major study conducted by the U.S. National Academies, titled The Next Decade of Discovery in Solar and Space Physics, Exploring and Safeguarding Humanity's Home in Space, highlighted the ongoing importance of missions like New Horizons. The report emphasized that one of the key challenges facing modern space science is the need to continue receiving observations from spacecraft, such as New Horizons and the legendary Voyager probes. These distant missions are currently the only sources of direct, first-hand knowledge about the environment of the outer heliosphere, the vast bubble carved out by the solar wind, and the space beyond it, where the influence of the sun gives way to the interstellar medium. The report also stated that as spacecraft move farther outward toward the boundary of the solar system, where the sun's power fades and interstellar forces begin to dominate, there remains an enormous amount left to discover. This region, often described as the frontier of the sun's domain, is poorly understood because it is so remote and inhospitable to exploration. The heliospheric boundaries are dynamic, shifting with changes in the solar wind, the sun's magnetic field, and the nature of the interstellar environment. Probing these areas helps scientists better understand not only our solar system structure, but also the protective bubble that shields Earth from high-energy cosmic radiation. The Heliophysics Decadal Report is considered highly influential within the scientific community, and its recognition of New Horizons carries significant weight. According to Alan Stern, the mission's principal investigator from the Southwest Research Institute in Boulder, Colorado, this acknowledgement serves as a powerful validation of the mission's continued scientific value. Stern emphasized that the report offers an independent confirmation from the broader research community that New Horizons is uniquely important in its ability to provide insights into the outer heliosphere. The spacecraft is now progressing toward one of its most anticipated milestones, crossing the sun's termination shock. This boundary marks the point where the solar wind, a continuous stream of charged particles emitted by the sun, slows from supersonic to subsonic speeds as it collides with the interstellar medium. The termination shock is a crucial marker in understanding the structure of the solar system's protective bubble. Although New Horizons is currently operating in hibernation mode, this does not mean that the spacecraft has stopped working. In fact, as Stern explained, it continues collecting heliophysics data around the clock. The spacecraft stores this information in its onboard solid-state memory, which functions like a massive, high-capacity flash drive. New Horizons entered hibernation mode on October 3rd of last year, a phase designed to conserve power and resources during its long cruise through deep space. It is scheduled to exit this mode on April 2nd of this year. Once it awakens from hibernation, the spacecraft will begin transmitting the accumulated data back to Earth through NASA's Deep Space Network, a global system of giant radio antennas essential for communicating with distant spacecraft millions or even billions of miles away. As for when New Horizons will actually cross the termination shock, Stern pointed out that predicting the timing is extremely difficult. The location of this boundary can shift depending on changes in the solar wind and the pressure exerted by the interstellar medium. Scientists can estimate when the crossing might occur, but no one can pinpoint the exact moment. Stern mentioned that the crossing could potentially happen as early as 2027, although it remains an open question. Because this is such a crucial scientific event, the team wants to make sure the spacecraft is fully alert and collecting targeted data during the earlier-than-expected window, to avoid missing the opportunity. Meanwhile, the spacecraft itself remains in excellent condition, despite having traveled billions of miles from Earth. Stern emphasized that New Horizons is in perfect health, with no major malfunctions or degraded systems. All 7 of its scientific instruments, which include cameras, spectrometers, particle detectors, and dust counters, continue to operate as effectively as they did the day the spacecraft launched. This is remarkable considering the harsh conditions of deep space and the vast distances the probe has traveled over nearly 2 decades. The performance and resilience of New Horizons are a testament to the engineering skill, careful planning, and robust design that made the mission possible. With its instruments still functioning at full capacity, and with new scientific frontiers ahead, New Horizons is expected to continue contributing meaningful data for many years. Whether it will encounter additional Kuiper Belt objects or transition into a new extended mission remains to be determined. But the spacecraft's continued health gives mission planners confidence that many more scientific discoveries lie ahead. Even as it drifts deeper into the dark, cold reaches of the Kuiper Belt, New Horizons remains one of humanity's most valuable windows into the nature of the solar system's unexplored boundaries, carrying forward the enduring spirit of discovery that has always driven space exploration.